All right, guys, so here's my filled in chart. Please verify that your chart looks the same as mine, so we know that we have not made any errors. Okay, so now you might wonder why do we need to do this? Why do we need to standardize these values? So the reason that we need to standardize these values is actually because we have to find our correlation coefficient R by hand, just one time ever. Now, why do we have to do it by hand when we have a calculator that'll give it to us without the calculation? We need to understand, just like with standard deviation, how standard deviation is affected by large or small values. We need to understand how R is also affected by those same kinds of values. All right, so I'm going to sketch a really, really brief scatter plot of my standardized values. So I'm going to standardize my values and then sketch it. So z sub x and z sub y. So you notice that any value, right, that was above our mean, right, like these values, was positive, and any values that were below the mean was negative. And these are very small values. So I'm going to stretch out my graph a bit. So this will be negative, I'll call this negative 0.5, negative 1, negative 1.5. I don't think it goes past that. Nope. And then 1, so 0.5, 1, and 1.5. And then for zy, yeah, seems like similar would be fine. So 0.5, 1, and 1.5. And then negative 0.5, negative 1, and negative 1.5. All right, I'm going to sketch these values in, and what you should see is a graph that resembles a positive correlation. So negative 1.34, and this is a super rough sketch. Something like right there. Negative 1, negative 1.1, negative 1.069 again, and negative 0.79, negative 6.6, comma, negative 0.7, positive 0.3, positive 0.3, 1.23, 1.4, about right there, and the same x value, y value is 1.1. And so what you should see is still a positive relationship happening. All right, so again, now why do we need to know that? I'm not sure if they're going to ask for something like that on the AP exam, but we have better have seen it at least once. All right, now that we've got our standardized graph, you need to understand the difference between your scatter plot and your standardized scatter plot. So a scatter plot in general will never have negative values. You can't have negative ages, you can't have negative weights, most things cannot be negative, okay? And same thing with your y values. So generally speaking, scatter plots will be in only the first quadrant, but a standardized scatter plot will have both negatives and positives for x's and y's. And it should resemble a similar shape to your actual scatter plot, which it actually does. It resembles a very similar shape. You see these 2 points are stacked. You see these 2 points are stacked. All right, so we're going to move on to, again, the whole goal here, which was to find R. So how do we find R? So R is equal to, let me make sure that you can see that. Yep, R is equal to the sum of Zx times zy over n minus 1. All right, so first we need to talk about what does this guy mean? The sum of zx times zy. So they're talking about each of these standardized values, these corresponding pairs. And so what we're going to do for the first one, we're going to take these two values. Here's our zx and zy, and we're going to multiply them. So I'm going to write it below. We're going to have negative 0.134 times negative 0.369. And we're going to add that to the next set of values, which is right here, here's my next ZX, ZY. So negative 1.069 times negative 1.108 plus, and so on and so forth. So I'd like you to, I'm going to do one more with you guys. The next set of values, right here, ZX, ZY. And so on and so forth. Let's see how many minutes into the video. No, we're only 5 minutes in, so I'm not going to stop. So I'm going to go ahead and do this. If you want to pause the video here, you may. All right, lots of calculator work. I got 5.87. I hope that's correct. If you got a different value, I hope that I was correct and you weren't. So R equals this, right? My ZX, ZY products summed up, which is what I've done, 5.87 divided by n minus 1. N is the number of pairs in the sample. So in this case, we have 1, 2, 3, 4, 5, 6, 7. So n is 7. Right? We had 7 data points. So 7 minus 1, which is 6. And I'm going to divide that value by 6. And I get R equals 0.9786. Now let's talk about what R represents. Remember, R is the correlation coefficient. It tells us how strongly related X and Y are. So how strongly related are your age and the number of pages you can read per minute. So now there's a way that I can confirm, and I really hope I didn't make an error here, right? And I'll show you how I can do that. So I'm going to go to Stat, Calculate. Now, when we go to Stat Calculate, we're always going to use, there's 2 different linear regressions. There's LinReg 4 and LinReg 8. And we're always going to use LinReg 8. They prefer A plus BX, not AX plus B. X list is going to be our list 1. Y list is going to be list 2. Frequency list, don't worry about it. Now, store regression equation. You don't have to do that, but I'm going to show you how to do that. So to store your regression equation, you go to vars, again, vars right here, yvars, and then you hit enter, and you can store it into any of these that you want. I'm going to store it into y1. So just hit enter, and then I'm going to calculate. So my regression equation, oh, look at that R value, guys. It is exactly what I had for R, almost to the 10,000th place, right? So again, you have to remember that we rounded each of our values right here, right? We rounded this value, we rounded this value, we rounded this value, we rounded this value, and then we rounded each of these, each of our products, each of these values. And so there's going to be a little bit of difference due to rounding, but you can see my my R value was really, really close. And so since my R value is really close to 1 or -1, right, I'd say that this is actually a strong correlation. Now earlier when I described it, I said moderate because on the scatter plot there were so few points it was hard to tell if they were tightly clustered. Now that I've actually been able to calculate it, I could upgrade that to a strong. If I didn't have R, moderate would be fine, but now that I know R, I would actually change my description to strong. And guys, that's how R is calculated. And will you have to do that by hand? Doubtful. If you watched the presentation by Darren Starnes and Josh Tabor, they said they could not imagine making students do this kind of tedious calculation to get this value when it simply shows up in your calculator. Now, for anybody who does not have an R value here, what you need to do is turn your diagnostics on. So you need to go to second, catalog. You need to go down to the letter D. Now you notice it's already in alpha, right? It says A right there for alpha. So you can just type in the letter D. The letter D is right here in green. And go down to diagnostics on. So you're going to have to scroll. And you're going to turn on your diagnostics, hit enter twice. And now if you go back to your stat calc lin reg number 8, you enter the same information. We're going to still store our regression equation in Y1. Now you should have an R value if it didn't pop up before. Okay, so what else does this tell us? Well, we also are given the line of best fit. So the line of best fit, they always write it as Y equals A plus BX, and A is your y-intercept, and B is the slope of the line. Okay, so the cool thing here is that our slope of the line, right, is given to us and our y-intercept is given to us, so we don't actually have to calculate either of those things. So it's y equals, in this case, A was, I'm looking back at my calculator, A was negative 2.516, so I'll go ahead and round it. So A is negative 2.516, and the slope B was 0.619, I would round that to an 8. Okay, so A, which is negative 2.516 plus B, 0.6198x. Now, in stats, AP stats, we never, hardly ever do I leave it in X and Y. So first of all, they want you to either define X and Y or use the words. For me, students make fewer errors when we actually when we actually use the words. So Y represented the pages read. So pages read equals negative 2.516 plus 0.6198, and then X represented age in years. Or you could just say pages read, or pages equals negative 2.516 plus 0.6198 times age. All right, now remember that these are called linear regression models. We're trying to predict Y based off of X. So there's a symbol that we have to use, and it's called a hat. It's Y hat. We never say Y. We always say Y hat because we're trying to predict the number of pages you read based off of your age and years. So always put a hat on your Y, always, because this is called a prediction line or a line of best fit, so they're not the y values aren't exact. All right, now that we've talked about how to write the equation of the line of best fit, let's talk about interpret the slope and the y-intercept in context. They're very, very, very particular. So when we interpret the slope, we always do it in the same way. Okay, so the slope. Here's my slope. I'm going to interpret that. Remember that this is a positive value. It looks like as age is increasing, right, in years, that our y value is predicted to increase as well. So as x is increasing, since our slope is positive, it appears that our y value is also increasing. So the slope, we will say it in context as x increases, don't forget units, y is predicted. You must use this word predicted or expected and then you can either say increase or decrease and then use units. So this is a generic description. Now we're going to fill it in based off of our context. So as age in years increases, pages read per minute is predicted to increase by 0.6198 years. Oh, let me rephrase that. So I'm going to stop right here. I haven't even talked about the slope yet. So here's my beginning, right? As age in years increases, pages read per minute is predicted to increase. All right, so when we interpret our slope, let me go back to the slope right here. It's 0.6198 over 1. And so these are, remember, our change in y over our change in x. So for every 1 year increase in x, y is predicted to increase by 0.6198. All right, so again, I'm going to write it right here. We have 0.6198 over 1, and this is our change in y over change in x, which is our change in pages read over our change in years. Now we're going to go ahead and go back and link that to our interpret the slope. So here's our final interpretation of the slope. As age in years increases by 1 year, pages read per minute is predicted to increase by 0.6198 pages. This is a perfect interpretation of that slope. Perfect interpretation of the slope. Okay, now let's talk about the y-intercept. So when we interpret the y-intercept, so I'm going to go back to here, right? Interpret the y-intercept in context. we want to say something about if x were 0, predicted y would be. And then sometimes that doesn't even make sense. Like in this case, we're going to get a negative for our predicted y, right? Our y-intercept, just to remind you, our y-intercept was right here, negative 2.516, which means negative 2 pages, right? That doesn't even make sense. So again, our y-intercept was negative 2.516. And so what that means is that if a person's age were 0 years, their predicted pages read per minute would be negative 2.516 pages. In this context, there is no useful information regarding the y-intercept, since no one reads a negative number of pages. Okay, so let me stop right here. I'm just going to say that this part right here, this is my not just interpretation. My interpret is if a person's age were 0 years, their predicted pages read per minute would be negative 2.56 pages. Now, if I wanted to reflect on that, in this context, it doesn't even make sense. It's not useful because no one can read a negative number of pages. So this is just extra information that you're allowed to add in, but it's not necessarily important. Sometimes the y-intercept does have meaning. In this case, the y-intercept, since it's negative, it doesn't make sense in context. All right, we're going to stop right here, guys. And so there's more to do with the notes. Actually, I think I want to finish off with one thing before I stop. We talked about the slope of the line. So now that we know what the slope is, right? The slope is 6.198. So the slope of this line is going up for each 1 unit in years. It's going up by 0.68, right? So can you picture this line, a best fit in here somewhere? That's a little off because I should have the same number of points above and below. So let me try that one more time. If I were to sketch this guy in, I just did a kind of a junky job, and I will do it again. So maybe more like ish, where I have about the same number of points above and below the line. Now, this is, the slope is 0.6198 over 1. The cool thing that you may not have realized that we found with our R value, right? Our R value, R is the slope of the standardized line of fit. So what we found when we found that R value, right? Our R value, it's the slope of this line, which is almost 1. It's a much stronger line, right, than this one. A steeper, I should say, a much steeper line. It's almost a perfect 1-to-1 correlation. And so R is the the slope of the standardized line of fit. All right. I know that was a lot. I hope you took it all in. We'll be doing chapter 8 notes. I'll get some feedback from you guys and see if you're ready for it this week or if you'd like to have a little more practice with chapter 7 before we move on. All right, have a great evening.